Hello, so you're joining us for Algebra 2 9.2 Part 2. So the things we're going to go over today are going to be radian measures, converting radian measures to degrees, and sketching some of these angles out. So the biggest thing that we're dealing with today is going to be using radian measures instead of degrees. So degrees is what I'm saying is like last time in 9.1 part, no, 9.2, sorry, part 1, I would have maybe given you the angle of 90 degrees and said, can you sketch that out for me? And you would have said, yeah. That would be this right here, that's 90 degrees, and you'd show me that angle and say, yay, that's 90 degrees. If I said, sketch me out 60 degrees, or even 160, you would have said, okay, that's about right here, and that would be 160, okay? So now what we're going to do is use its equivalent radian measure. So again, degree is super easy to remember because it has a degree symbol. You're much more comfortable using degree because you've used degree measures most of your life when talking about geometry or any angles that you would have had to measure or know to measure up. Now, moving on to a little bit deeper of a tray, and we're dealing with radian measure, that's going to be something representative through pi. So radian measures and degree measures can both represent the exact same angle, they just look a little bit different. Degrees have that degree symbol, radian measures have a pi symbol within them. So if we go to talk about, again, that unit circle, I'm not drawing out a graph, I'm drawing out the unit circle. The way that you're going to label this, again, if in degrees, it was 0, 90, 180, 270, and 360. Those degree measures still exist. They're still there around my unit circle, only now we can represent them with its equivalent radian measure. So again, radians are in pi. So this radian measure still starts at 0, and we work our way around. Again, it's like a 90-degree addition, but instead we can consider it a half a pi, or pi over 2 would be how we're going to continue adding around and adding around and adding around. So again, each individual axis point, so here to here, here to here, there, down there, and there, back around, adds on 1/2 pi. So that when we say 1/2 pi, it'd be like 1/2 times pi. So any of these numbers we represent will be the fractional version associated with that pi version. So the representative of 1/2 times pi simplifies to pi over 2. So you can think of these as pulling out that fraction from the denominator and the numerator and saying, okay, this is 1/2 of a pi. And then I'm going to have 2 pi and 3 over 2 pi, just pi. So we go from 0, we add on pi over 2. Or 1/2 a pi. So up here is pi over 2. We continue adding on another 1/2 a pi, which leads us to pi. And then another 1/2 of pi, which would be 3 pi over 2. And lastly, another 1/2 a pi, or pi over 2, which would lead us to 2 pi. Okay, again, these measures always stay. They are consistent. They are never changing. Those angle measures in degrees and radians will always be 0, pi over 2 pi, 3 pi over 2, 2 pi, and same for degree measures. So the important thing to remember here is pi and 180 are equivalent. 0 and 0 are equivalent, 360 and 2 pi are equivalent, pi over 2 and 90 are equivalent, 3 pi over 2 and 270 are equivalent. The difference is the representation of them. Okay, they mean the same thing, they equal the same measure, they're just different representations, degrees versus radians. So your biggest struggle here will just be trying to deal with the fractions of the radian measures. Degrees are super easy. If I asked you to draw 60 degrees out in degree measure, you'd be like, oh, it's between 0 and 90, so it's perfect. If I asked you to draw out pi over 4 though, or pi over 3, you might say, I'm not so sure where that one goes, because you might be still a little bit confused with those fractional versions of things. Okay, so So just 1 second, I'm gonna pause this to grab a couple different marker colors. Okay, we're back. I grabbed a couple different marker colors. So here's the thing. I'm going to show you most of the entire unit circle. You are not going to likely memorize this, especially not this year. Next year in pre-calc, you will have to if you're taking that. But this year for Algebra 2, it's more going to be trying to understand it and relate fractions back to this unit circle. So I am going to show you kind of some of the values you might deal with, just so you can try to kind of visualize where those would lie in a unit circle based on what the unit circle looks like in this first quadrant. So in this first quadrant, we first divide things in half. Okay, so when we divide things in half, and that doesn't need to have an arrow on it, I don't quite know why I did that. When we divide things in half, I am taking 45-degree angle, 45-degree angle. So I'm only going up to 45 degrees. But I want to know, what is that as a radian measure? Okay, so there's a couple different ways you can do this. The first way I'm going to teach you, though, is simply by trying to rationalize this out. So if from here to here is 1/2 pi, we want to cut 1/2 in half. Okay, so if I am dealing with, this is going to seem a little silly, a full pi, and you say I'm taking half of it, and this might be the 1/2 of a pi that you're taking. I need to cut this 1/2 also in half, and now I'm only taking that 1/4 of a pi. Okay, so instead of having pi over 2, that 1/2 pi, now I have 1/4 of a pi, so pi over 4. Some other measures that are definitive on our unit circle is going to be cutting our entire top half of this pi into thirds. So thirds would be right here, representative of 60 degrees, or pi over 3. Oh, that did not show up very well. Let me try to look. A little bit better there. And last but not least, we have our division of 6. So this time we have 30 degrees, or pi over 6. So what's happening is we divide into 6, we divide into fourths, we divide into thirds, we divide into halves. So all of these measures are smaller than 1/2, okay? All of these measures count all the way around the unit circle. So over here, I would have 5 pi over 6. I would have 2 pi over 3. And I would have 3 pi over 4. So once you get to pre-calc, we will do an in-depth dive as to how this unit circle is created, how you can create it yourself. Right now, within Algebra 2, we're really just trying to get you more comfortable using it, reading it, representing it, and trying to decide where your specific angles lie based on their degree or radian measure. I'm not going to be able to ask you, and I don't want to have to ask you, and I won't, sorry, not that I won't have to, I don't want to have to, is that I won't ask you this year how to create the unit circle and how the ins and outs of its work. That's more of a pre-calc topic. For now, I want you to get comfortable with it. So I want to show you something, specifically looking at the blue lines up here, which if you can't tell, that would be these two right here. Focusing on just the top half of the circle, if I look at just those blue lines, what's happening is those blue lines are cutting my entire top half into thirds. From here to here is a third, here to here is a third, there back to this line is a third. Thus, I go from 0, 1 pi over 3, or 1 of that third, 2 thirds, 3 thirds, which simplifies down to pi. Then what I also have is, if you look at the blue and this red or dark red line, that's cutting my top half into 6. So we have 1 6, 2 6, 3 6, 4 6, 5 6, 6 6, which again simplifies down to that 1 pound. Last but not least, if you focus on just these pink lines, those pink lines are cutting this into equal fourths. From here to here, 1/4, 2/4, 3/4, 4/4. So what's happening essentially is these main division lines on this unit circle are just dividing lines. So we divide in 6 times, we divide by 4 times, we divide by 3 times, we divide by 2 times, and that's how all of these different radian measures on this specific unit circle are being created. But we can throw you any radian measure and ask you where is that going to lie. Not all of them are going to be specific division lines that are represented on that unit circle, okay? So what's going to be your job is we may say, sketch the angle 3 pi over 4 on your unit circle. And without or not on your circle, on your graph, you would have to decide, well, does 3/4 lie between 0 and 1/2, 1/2 and 1, 1 and 3/2, 3/2 and 2. Okay, you can almost kind of not pay attention to that pi symbol and just look at the fractional version of it. This is 1/2, this is 1, 3/2, and 2. So you will be trying to determine, is every one of these fractions between these values, these values, these values, and these values, okay? You can look up a full unit circle if you would like to on this. The unit circle does have values in quadrant 3 and quadrant 4 for those radian and degree measures. I'm not going to go too deep in them into the day. I'm not going to go too deep into them today, as that's not kind of what we're trying. We're trying to get you more used to drawing these out on your own without having the exact representation of the unit circle. Okay, that is radian measures with the relationship to degrees. So because many of us will not be quite as comfortable using radian measures as we are as in using degrees, I do want to show you how we are able to convert degrees to radian measures and radian measures to degrees, because again, they're very equal representations. They just look a little bit different. So if I were to take a radian measure, so I'm going to I'm going to write out radian measure. If we are going radians to degrees, okay, again, so I'm doing radians to degrees. You take your radian measure and you multiply by 180 over pi. If you are going from degrees to radians, you take your degree and multiply by pi over 180. So it is truthfully pretty simple. You just have to be pretty careful as to your math with this and making sure that you can know and understand how to work with fractions a little bit and canceling things out. So as an example, let's do one that's going from radians to degrees. So again, I'm giving you a radian measure such as 3 pi over 4. And what I'm asking you to do is convert this into degrees. So every single time, if you're asked to convert into degrees, you will multiply by this 180 over pi. That number is never going to change. It's never going to be some other number over pi or anything else. It's always 180 over pi, regardless of what this radian measure is. Okay, so one of the big things that's going to happen here is our pi's are going to cancel out, okay? So when you have something in the numerator and in the denominator that is the same, they can cancel out. So my pi's are canceling. Then I have 3 times 180. You still see over here? Yep, which is 540. And then 4 times everything's canceled over here, so technically just 4 times 1. So 540 over 4. So It's a little late, so I'm not doing math in my head right now. We end up with 540 divided by 4, which is going to give us 135 as a degree measure. Okay, so that would be the representation of 3 pi over 4 as a degree. We can also go the opposite way. So I'm going to use the exact same numbers, just so you can see how they go back and forth. So now if I'm given a degree, let's say I'm given the degree measure of 135, and I want to go to radian measures, or I want to go to a value that has a pi in it. Every single time you'll multiply by pi over 180. Again, this is going to be happening every single time. It's never going to be a different value. I wrote that a little bit small. Let me write that a little bit bigger. Okay. So when we do that, what's happening is we say, okay, this is a whole number multiplied by a fraction. So you can write this as if it's 135 over 1 and multiply fractions straight across. So 135 times pi is 135 pi, and 1 times 180 is 180. So because we already used this example, we know what this should simplify down to. 135 divided by 180 will give you the fraction 3/4. That pi remains. So your ending answer, or your representation of 135 degrees in a radian measure, is 3 pi over 4. So they are equivalent, they mean the exact same thing, they're different representations though. Okay, so again, every single time, radians to degrees multiplied by 180 over pi. Degree to radians multiplied by pi over 180. Notice it's just as simple as flipping the pi symbol. So it's a reciprocal. So if your pi is in your, where am I trying? If your pi is in your numerator, it should multiply your denominator. If your pi symbol is non-existent, it should then go into your numerator with what you're multiplying by. Okay. The very last thing I want to show you is how to find coterminal angles. I'm going to remind you what a coterminal angle is. So last time we used the example of 60 degrees. So this is my 60 degrees. Here's my starting point. There's my stopping point. So what we had to do was find an angle that started and stopped in the exact same place. So start here, go all the way around, end up at 60 degrees. That was a bad marker. Start here, go all the way around, end up at 60 degrees. So we started and stopped in the same point. The other way we went was start here and go backwards. Both of those are coterminal angles, and graphically, this is a lot easier, I think, to see. But what essentially happens is we take the angle at hand and we add 360. We take the angle at hand and we subtract 360. That is how you find both of these coterminal angles. In this case, it would be 420 degrees and negative 300 degrees as both of these coterminal angles. Keep in mind, we can also do this with radian measures. It looks the exact same way. The only difference is instead of 60 degrees, we would have pi over 3. So we again went backwards, starting point to ending point, and all the way around starting point to ending point. Only we have to change this into a radian form. So instead of starting with 60, the angle at hand is pi over 3. And we have to add and subtract 360 degrees represented as a radian measure. So we know that this is 0 to 360. We also know it's 0 to 2 pi. 2 pi and 360 are the equivalent measures here. So we will be taking pi over 3, and we will be adding it to 2 pi. We will be taking pi over 3, and we will be subtracting 2 pi. So here's where most of you are going to get caught up. And it's not because you don't know how to do this, it's because most of us can be a little bit uncomfortable with this. It's just finding a common denominator. You know how to do it, but it's one of those things that you aren't super confident in, probably because you haven't done it in a long time. And we don't tend to like fractions, but we are better at them than we choose to think that we are. So when we deal with a whole number and a fraction, we like to write that whole number over the value of 1. Every number is a rational number. Every whole number is written over 1. So when you go to add fractions, one huge thing you need is a common denominator. Here, I have 3 and 1 as my current denominators. We don't like to get smaller, so I'm not going to take the 3 down to a 1. We tend to like to get larger, so I'm going to have a common denominator of 3. Again, between 1 and 3, 3 is my best common denominator between those two things. So I have to ask myself, okay, to turn 1 into 3, you need to multiply by 3. What you do to the bottom, you must also do to the top. So I have to multiply my numerator by 3 as well. My new addition that I have going on here, my new sum will be still pi over 3 plus, let's see, 2 pi times 3. So keep in mind, pi here is an irrational number being represented by a symbol. So you are multiplying still your like terms. So 2 pi times 3, we're multiplying 2 times 3, which is 6, and the pi follows suit after. 1 times 3 is 3. Now we have a common denominator, so we can add. 1 pi plus 6 pi is 7 pi. And again, you do not add the denominators, that's the point of the common denominator. So our first coterminal angle would be 7 pi over 3. And again, I can continue adding 360 or can continue adding 2 pi to find infinitely many coterminal angles. In this case, we're going to do the exact same thing. Write that 2 pi over 1. Again, we've already done the hard work here of finding my common denominator is going to be 3. So again, I'm multiplying my numerator and my denominator by 3, giving me pi over 3 minus 6 pi over 3. Okay, here's where you have to be super careful. This is 1 minus 6. 1 minus 6 is going to go negative because I'm taking 1 and subtracting something larger than it. So this goes into negative 5 pi over 3. If you do this correctly, you will end up with a positive and negative version for the most part, especially if you're starting with a positive angle, you'll end up with a positive and negative coterminal angle if you're doing one of each. Okay, that is how you're going to find coterminal angles dealing with radian measures. We know how to do them with degrees. Some of you will always try to convert back to degrees and then find it. That's okay, but I do want to still make sure that you do know how to use it. Do know how to find coterminal angles using just radian measures. If you want to kind of practice converting to degrees and find coterminal angles using degrees, you can do that for a couple of them, but I do want to make sure that you still know how to do it using their radian measures as well, because going into pre-calc will need you to be very comfortable using radian measures. Okay. You do have a worksheet over this, and it covers the 3 things we just talked about. So drawing their angles in radian measures, converting between degrees and radian measures, and then finding coterminal angles. Okay, let me know if you need any help on that.